Okay, this second half is actually going to talk about the end behavior of polynomial functions. Based on the degree and the leading coefficient, I can predict what this graph is going to look like. So what I want you to do is I want you to think about the two function families that you already know a lot about. You know a lot about lines, and that is an odd. You know a lot about quadratics, and that is an even. A line is an odd because it is a degree of 1. A quadratic is even because it is a degree of 2. All odd functions have the same end behavior, and by end behavior I mean how is it ending? Is it ending pointing up to the right? Is it ending pointing down to the right? So these end behaviors are all indicated by the degree and the leading coefficient. So the first thing I want to say is these two graphs over here are both odds. The degree of this would be an odd degree. I don't know exactly what degree it is, but I know it's odd. And I know that because one end is pointing up or down and the other end is doing the opposite. Okay, I want you to remember what a line looks like. I either have a positive line or I have a negative line. So a positive line goes like this. A negative line goes like this. Okay, so the red graph underneath would be a polynomial, so it's more than 1. And so here's the other thing we need to know. We need to know that the leading coefficient, let me erase that and make it skinnier. The leading coefficient must be positive. The leading coefficient here must be negative. Okay, so now that I know that, let's go to the other side and let's just talk about the other two graphs. Notice these both end up or both end down. The end behavior here are both up, and the end behavior here are both on the bottom are both down. This is an even function, so this would be degree even. And again, I said I wanted you to think about a quadratic because the quadratic is the even function that you know. And if I put the parent function of the quadratic on here very roughly, notice that is a positive quadratic and they both end up. So the leading coefficient of this one would be positive. Okay? Notice, remember the parent function, when I put a negative in front of it, reflects over the x-axis. That would be a negative, and therefore that would be a negative leading coefficient. So the leading coefficient here, and I wanted it to be black, sorry. The leading coefficient here would be positive. The leading coefficient here would be negative. Okay, now let's talk about end behavior. So the statement that you need to learn and you need to memorize is kind of long. So let me see if I can fit it in here. It says, if x approaches infinity, what does the function approach? So what I'm asking you is, as x gets bigger, do I approach positive infinity or negative infinity? Well, this goes to positive infinity. Okay, so if, and actually that should be as, sorry. As x approaches negative infinity, what does the function approach? Okay, so again, as x approaches negative infinity, so as my x gets smaller, what's happening to my function? It's also approaching negative infinity. And you will have to be able to write this sentence out. So let's jump down to the bottom one. The degree of odd, but it's negative because the right side is pointing down. So as x approaches positive infinity, what does my function approach? So as x goes positive, my function is actually decreasing, so it's approaching negative infinity. The other one is as x approaches negative infinity, my function approaches what? As x gets smaller, my graph is actually increasing towards the infinity, so it would approach positive infinity. Okay, the other one. Let's look at the two on the right. So let's talk about the end behavior here. So as x approaches positive infinity, the function approaches what? So as my x gets bigger, my function is also approaching positive infinity. Now as x gets smaller, so as x approaches negative infinity, the function of x approaches what? So as my x is getting smaller, my function is still going up, so it's approaching positive infinity. Okay, I want you to pause the video now and go ahead and try to do this one in the bottom right corner, and then come back for the answer. So, as x approaches positive infinity, the function approaches what? As x approaches negative infinity, the function approaches what? So as x gets bigger, you can see my function is getting smaller. As x gets smaller, my function is getting smaller also. So you can see on the odd behaviors, so these graphs over here, let me see if I can find something light. On these graphs over here, okay, these are my odds, and therefore have opposite end behaviors. One will end positive, one will end negative, based on my leading coefficient. The two graphs to the right, both their end behaviors are either positive or negative, and again, they're even, but the end behaviors are based on whether they're positive or negative. Okay, so you guys try this graph. So I want to know what the degree is, what the leading coefficient is, and what the end behavior is. So what is the degree? What is the leading coefficient? And what are the end behaviors? So remember, the end behaviors are two sentences. As x approaches positive infinity, what does the function approach? And as x approaches negative infinity, what does the function approach? I always go at it from the x because that's my input. So the degree of this has to be odd because one ends up and one ends down. So the degree of this would be odd. Before, the reason I said that I always compare this to a line, the odds to a line, is because I want you to remember that a positive line goes up to the right. So the leading coefficient here has to be positive because a positive line goes up to the right. So all odds, if it's positive leading coefficient, it will go up to the right and down to the left. Rise to the right, fall to the left. Now let's talk about end behaviors. If end behavior, as x gets bigger, what is my function doing? My function is getting bigger. It's going towards infinity. As x gets smaller, what is happening to my function? It is also getting smaller. Okay, describe the degree, leading coefficient, and end behaviors of the given polynomial, and then we're going to sketch a rough graph of it. So describe the degree. Well, this is in standard form, so my degree is my largest exponent, so my degree here is 3, which is an odd number. My leading coefficient is the number in front, which would be -1. That's a negative. So I know with a negative, okay, think of a line. Sketch this in here. Just think about a line. This is what a negative line looks like. Okay, the line has the same end behavior as every odd. So I know my end behavior is as x approaches positive infinity, the function is actually going to approach negative infinity. And as x approaches negative infinity, my function is actually approaching positive infinity. Now let's just make a table, throw some points in there. I automatically know from this that this is going to be my y-intercept. So we're going to put a point there. Let's plug in 1. If I plug in 1, I'm going to get -1 plus 1 plus 3 minus 3. It would be 0. So I found a root. Okay, let's plug in -1. If I plug in -1, remember I'm always plugging into parentheses. This will be -1 cubed is -1, so this becomes +1. This becomes +1. This becomes -3 minus 3. So 2 minus 3 is -1 minus another 3 is -4. So -1, -4. Let's plug in 3. If we plug in 3, we get 3 cubed, so that's going to be -27 plus 3 squared would be 9 plus 3 times 3 is 9 minus 3. So -27 plus 9 is -16. No, -18. So I just put it in the calculator, and so if I plug in a 3, I get -12. So 3, this is going to go about here. It's a little to the left, sorry. And that's going to have to be good enough. And now let's just plug in -3. Where's my eraser? That's not what I wanted. Okay. Here's my eraser. Oh, I can't erase anymore. Learning something new about this program all the time. So we're just going to plug in -3. If I plug in -3 here, I get a -27, so that will be a +27. If I plug in -3 here, I still get a +9. If I plug in -3 here, I actually get a -9 minus 3. So 27 plus 9 is 36, minus 9 minus 3. So if I plug in -3, I get +24, which we know is going to be way up here. So here's what my function rough sketch looks like. Let's see. Yep. Okay. Kind of poorly drawn because this wouldn't be a function because I have some verticalness going on here, but you get the drift. Okay, so my time is almost out, so I'm going to let you do this one on your own. Just remember the degree is this number 4 right here, which means I'm even. My leading coefficient is the 1 in front, which means I'm positive, which means my end behaviors will both be positive. So as x approaches infinity, f of x also approaches infinity. As x approaches negative infinity, f of x also approaches negative infinity. Enjoy. See you soon.